going to try and explain the activity for carbon dating. This is the activity on our Google Classroom, and there are directions here on what to do. So it says first read through the activity packet. So when we open that up, we have our activity packet. This first page, you can either reread or skip. It is just a review of what carbon dating is and basically how it works a little bit, kind of review from the notes. You need to read this second page on the scenario. It explains that they found bones of an unidentified female. It is really important that you remember that this scenario happened in 1998. That will come into play later. And here are our missing persons. You may also skip page 3. Originally, this lab was created to be done in the classroom, where we actually simulated half-life by cutting up a bunch of pieces of paper, putting them in shoe boxes, and spilling them out and seeing how many showed up heads and how many showed up tails, thus removing half of them each round and doing this multiple rounds. So we figured out how many little tiny pieces of paper we were left with, simulating the radioactive decay. It takes a long time, and basically half of them decay each time. So I feel like it's kind of a dumb lab. We're going to skip doing that. Instead, I'm just going to give you the data. So here's our last page, which is important. Now, it is important that you understand that I am using a fake radioactive element. I've named it C-14 because in science, if you figure it out, you get to name it after yourself, with a half-life of only 10 years. Normally, we'd be using carbon-14, and the half-life is 5,730 years. But that makes for a very, very large graph that I don't have to deal with. Our graph would look something like this with carbon-14, where you have your years on the bottom and the number of atoms on the side, and these numbers would be all very big, so we're not going to use that kind of graph. Instead, I want you to make a graph using this data. Now, you can do that on your own, and if you don't have graph paper, I've supplied some for you. You can print that out. But it's actually a lot easier if you just take this data and plug it into a Google Sheet. You put the years on the top, so 0, 10, 20, 30, 45, 50, 60, and then the number of atoms remaining in the sample on the bottom. If you highlight it all and you click this icon right here, Insert Chart, it will make it for you. So you can actually even cut and paste this chart into your worksheet. Like so. And then you can just turn it in as one thing. You don't have to take a photo. If you do make one on your own with graph paper, then please take a photograph and upload it as well. Now here is where it comes into play. And I'm not going to use these numbers because I'm not going to do your work for you, but let me explain. The way this chart works is it shows us how many atoms there will be of our substance. In this case, it's C-14. In real life, it would be carbon-14 at any given time. You could do this mathematically, absolutely, or we can cheat and use the graph. So in our case, we started with 2,200 atoms. If I were to tell you that I found skeletal remains where half of the atoms had been gone, you could say half the atoms are gone, so half of 2,200 is 1,100. I could come down to my graph at approximately 1,100. I could draw a line over to where my graph is, and I could come down, and where I drop down, that's how many years old that skeleton is. In that case, it would be 10 years old. In our case, we have a certain amount of atoms have been lost. It says 90% has been lost. So you have to figure out if 90% has been lost, then how much remains. So of 2,000 200, if it's lost 90%, it has a certain amount of atoms remaining. When you figure out what that number is, you find that number on the side of your graph, you draw a line till it hits the curve and drop it down, and estimate how many years old that skeleton is. Now that's not the end. Let's say you find out it's 18 years old. Well, then you have to go back to when the body was found. In this case, it was 1998. So we'll take 1998 minus however many years old the skeleton is, and that will give us the date the person approximately died. You can then match that up for our missing persons report. Now, it is key that you remember that the person had to go missing before they died. So if, for instance, you see this person went missing in 1985, this person went missing in 1990. So if I find a number that says 1989, I don't pick Mary Sparks, even though it's only 1 year away, because Mary Sparks didn't go missing until 1990. She couldn't have died the year before she went missing. So when you have a number, by using your graph to find out how many years old the skeleton is, and then subtracting that number from 1998, you're then looking for the person that went missing the closest to that number, but they had to go missing before that date. Once you have that, you can then answer the question of who the bones likely belong to and explain how you got there. The question 3, you're actually going to use the graph in reverse. So instead of me telling you how many, or you figuring out how many atoms there are to find out how many years, I'm telling you, what if you just go to how many years old, how many atoms would be left? So we're going the opposite direction. We're going over in years and up to the chart, and then over to find the number of atoms. So I'm looking for how many atoms after 5 years and how many atoms after 55 years. These next 3 questions you should be able to get if you think it through. Why would it be important to know how many atoms were there in the beginning? Also for 6 is just your opinion. And number 7, I want you to come up with a scenario that this could be useful other than the one that I showed you here in this particular scenario. Come up with another scenario that it might be useful. I hope that helps. If you're still struggling, come see me in my office hours. Again, those are Wednesdays from 2 p.m. to 2:45 every Wednesday on Google Meets. I hope that helped. I'll talk to you later.